Sir, it's
Record can start, right?
a very hot topic. What are the different challenges as well as the EV technology. So I think everyone knows about the EV, that is electric vehicle. So nowadays, because considering the environmental, pollution, the EV has start growing rapidly, and also lots of technology is being introduced into the EV sector, and not only in the EV sector, in the EV vehicles. So because of the boom in this EV sector, there are also lots of job opportunities present. Just we need to take a interest in which department or in which part of the EV we are interested. So there are different various part of the EV related to modeling, design, simulation, battery, motor, controller, charger. So there are a number of job opportunities which is being provided into this electric EV sector. So based upon the interest as well as your interest to know about this component or other part, so you can gain more skill into the particular domain. So today we'll start discussing. So first of all, like the agenda, I'll first talking about the agenda, that is the necessity of the EV. Then we'll talk about the BEV technology, which is battery electric vehicle. Then the challenges in the EV. Then HEV, PHEV, fuel cell, HEV. Then we'll have a start clearing, or you can say question and answer or query session. So let's move towards the next slide, which is about like why electric vehicle necessary now. So we know that the phenomenon global warming, which is caused due to the greenhouse gases. So greenhouse gases are mainly caused due to the emission of CO2 and nitrogen family, nitrogen nomenclature. So because of this emission, the CO2 emission, so it can be either from factories, industries, as well as the transportation. So what we see that the dominating part from the for the emission of CO2 is from the transportation. So because of that, the EV has gained more popularity because the EV vehicles did not have any CO2 emission. So now you can see the graph, like the CO2 concentration, like 1200, 1400, 1600, 1800. Then when we see into the 2000, now it's 2020. So as we are moving day by day, the CO2 emission and also it is increasing day by day. So we need to take care of our environment. So for that, the EV is a very good concept, because of which we can get a new concept of vehicles, as well as in the transportation in commercial or industrial purpose. Now here you can see also the why electric vehicles necessary. I already told that CO2 emission can be from the industry as well as the transportation also. So from transportation, either we can go to the electric vehicles, because electric vehicles didn't have any CO2 emission. Because of that, the clean and green transportation is available. So to reduce the CO2 emission, we are moving towards the electric vehicles. Now, if we talk about the emission regulation, so we have seen like BS4 engine, BS6 engine, and the BS7 engine. So nowadays, the vehicles which are most commonly BS6 or BS7 engines are mainly there. But you can see the CO2 emission, the carbon monoxide emission, the hydrogen carbon, as well as the nitric oxide. So you can see while traveling 1 kilometer, how much CO2 as well as the CO, the SC and the nitrous oxide, how much is the emission. Like you can see while traveling 1 kilometer, the BS6 engine, which is Euro 4, it generates this much of carbon monoxide and the other hazardous components. So if we talk about the BS4, BS6, you can see the carbon monoxide is less, but as compared to BS4, and also the emission of nitrous oxide, the particulate materials like other components, other hazardous components which are leading towards the CO2 emission. If we talk about the BS7 engine, now the BS7 engines are getting like into the development. You can see the like the carbon monoxide, like it is not given the exact consumption, or the emission of carbon monoxide and the nitrous oxide and the particulate material. So, and also there is like if we develop a BS6, BS7 engine, the CO2 reduction will be reduced by 15% by 2015, but by 2030, and the reduction will be by 31%. So BS6 7 engines are good as compared to BS6 as well as the BS engines. And then we talk about the battery electric vehicle. So into the previous slides, we talk about the engine, the BS6, BS4, and the BS7 engines. Now we'll move towards the battery electric vehicles, like because this session is moreover focused onto the electric vehicles. So we'll talk about battery electric vehicle. So first of all, the main components. So talking about the main components, you can see onto the screen that the electric vehicles has a battery pack. So you can see this is a EV battery, which is mainly made up of lithium-ion batteries. Then it has a quick charge inlet, which is used for charging purpose, like to charge the battery. Then it has a power converter. So power converter, it can be either a rectifier or inverters. So based upon the AC to DC conversion or DC to AC conversion, power converter do the required conversion. Like if the motor, if we are using a AC motor, then the battery will convert the DC power to DC power. Will convert that DC power to the DC motor. And then there is no need to DC to AC conversion, but there are motor drives which are connected to control the speed of the motor, like as and when required. And also you can see the sorry, this battery pack. So inside the battery pack, it has BMS, the BTMS. The BMS is the battery management system, which is responsible for managing the cell balancing, the temperature, so that it manages that the each and every cells is up to charge, like it didn't over discharge or overcharge. Then we have different converters like choppers, you can say, to step down the required voltage. Like there are auxiliary components in our electric vehicles like indicator, headlights, and other components. So that components require less amount of voltage. So for that, the choppers are used. So chopper, what they do, they convert the high voltage to low voltage DC. So these are the basic components you can see onto the screen of the EV. Now we move forward. So this is an example of a Tata Nexon. So Tata Nexon, this is an electric vehicle by the Tata Motors. So you can see that it has a EV battery which is made up of lithium batteries. So can anyone tell me, in India we have found a lithium? So in which state or which region? Can anyone from the participant can tell me? Yeah, am I audible?
Yes, audible.
So
Yes,
can
sir,
anyone
audible.
tell me?
Sir, Rajasthan and
Yes,
Ladakh.
Rajasthan and Ladakh. Yeah. Okay, Rajasthan and Ladakh. Yeah, so in that region, the lithium is being found. So because of that, the battery into the India, like what we do, we export, we get import battery from the China, and then here what we do, we just get that battery and we do the battery pack assembly, and then we fit it into the electric vehicles, and then we move our electric vehicles. So as we got the lithium in our country, what will happen? The production of lithium ion batteries, the cost will be reduced. The battery cost of the lithium ion batteries will be reduced, and because of that, the cost into the electric vehicle will also reduce. So if we talk about the electric vehicles, like everyone say, it is very costlier. So the battery or the cell, the battery pack which is being used into that electric vehicle is costlier. Because of that, there is high price of electric vehicles. Now this is the lithium ion which you can see, like the Tata Motors, just into the previous slide we have seen here. Now if we talk about lithium, I was talking about more lithium. So there are also other chemistry which are lead acid, the nickel metal hydride, and the lithium ion. So lithium ion, they have different nomenclature. You can see the cobalt, manganese, and the phosphate. So onto the screen, you can see about the different specifications. So first one is the specific energy density. So energy density is means that in 1 kilogram of that lithium lead acid battery, this much of energy can be stored. So if we do the comparison between the lead acid battery and the lithium ion batteries, so you can see how much is the how much is the difference. Like if you see about the lead acid battery, it has less energy density. Then we talk about the cycle life. So lead acid batteries has less cycle life as compared to lithium nomenclature batteries. And also the cell voltage, uh, cell cell voltage. So lead acid batteries, nickel metal hydride, and the lithium ion batteries, they has a nominal voltage which you can see onto the screen. So for lead acid battery is 2.24, then we have 1.5 for NIMC MH, and then for lithium we have 3.2 and 3.7 and 3.8. So these are the variations which you can see onto the screen of the different chemistry. Then we have a graph, or you can see onto the screen, like since when we are using these batteries. So in late 1800s, 1990s, 1991, 1996, and 1999, though these are the year by which these batteries is being used. So if I talk about that EV technology, so if I say that EV technology is not a new technology, like in late 1800s, EV were also present there. But at that time, there were no rechargeable battery available. Like what was there, if we the vehicles, once the energy is stored into the batteries was used, those battery pack what needs to be replaced. So because of that, every time the change in battery pack was there. So due to which the cost of that electric vehicle was very high, and also it was very hectic. Like every time when we drive a vehicle, we need to change the battery pack. So it was also a raised anxiety at that time. So due to which at that time the EV batteries was a failure, and also because of the Ford assembly line in by 1912, the ICE vehicle was more into the market. Like there was a problem self-starting, or you can say knocking, that problem was resolved, and because of that the EV gain more the ICE vehicle start gaining more popularities, and there was a decline into the EV. But again, due to the environmental thing, and also the new technology, and also the new research and development and new innovations, this EV batteries start gaining again more popularities. Now here are the different parameters. So you can see, first one is the voltage, then we have the capacity, then we have the energy stored. So voltage, so each cells of the battery or the cells of the different chemistry has a particular voltage level. So I already showed you into the previous slide, which is sorry. So you can see the voltage into the different chemistry. Then we have the capacity. So capacity is nothing but the AH. So whenever we go to buy a phone, we have seen that mAh. So it is like 5000 mAh, 6000 mAh. So 5000 mAh is nothing but milli. Here is the milli. So if we configured it, it is 5 Ah. So it means that 5 ampere of current can be withdrawn from that battery pack in 1 hour. If we reduce the current value or increase the current value, so what will happen? There will be the change in duration of time. Like if we extract 10 ampere of current, then what will happen? That 10 ampere of current will be extracted in half an hour only. If we extract 2.5 ampere of current, then it will be extracted into the 2 hours. So this is how the battery works, the AH. Then we have the energy stored. So if we talk about the voltage and capacity, so voltage, its unit is voltage, and capacity, its unit is A and H. So A and H. So if you talk about the energy stored, so energy is nothing but the product of power and time. So power, we can see if we talk about the electrical, so V into I, which is voltage into current, so that is power. And if we multiply that H, which is time, then we'll get the energy stored. So if we multiply the voltage and the capacity, we'll know that the how much energy is being stored into that particular cell. Then we have the state of charge. So state of charge, it is like whatever the percentage, like when we see our phone, there is a percentage showing that how much of energy is being stored, like it is in percent, 20%, 35%. That is nothing but the SOC state of charge, which represent that this percentage of energy is being stored into the battery pack, which is being used in our phone or the EV. Then we have the depth of discharge. So it is actually the 100 minus SOC, like how much energy is being used. It is the depth of discharge. Then we have the energy density, power density, and the life cycle. So life cycle is thing which means that in how much duration we can, like for how long we can completely discharge or charge our battery pack, like for how many times or how many durations. So these are the battery terms which are very important as we move towards the battery. Now the EV control system. So we know that driving a vehicle, electric vehicle, is a very dynamic process. Not only electric vehicle, but the ICE vehicle also. So if we talk about the ICE vehicle, we have here the gearbox and accelerator. So if we talk about the motor, how we will be controlling the speed, like when we have to increase the speed, when we have to decrease the speed, how everything will be controlled. So for that, a control system is being fitted into the electric vehicle, which is the motor drive, to control the speed of the motor. So you can see onto the screen that it is using an inverter. So inverter, it does the AC to DC to AC conversion, and like the EV battery, so battery stores energy in the form of DC, and because of that DC conversion, DC is being converted to AC by the inverter. You can see the IGBT switches, the motor drive, the sensors, the converters, the EV control, which is the ECU. Then we have the compressor with motor assembly. So there is the whole vehicle control system to control and manage the vehicle speed for the different motor. Like if we talk about if we are using a DC motor, then there are controllers which is connected to directly to the battery pack, and it is connected to the accelerator, and then it is connected to the motor. And because we are pressing the accelerator or giving the throttle, okay, so because of that fluctuation into the voltage or resistance, there is change in the voltage level, and because of that the speed varies. Now we talk about the battery, the motor controller. Now we talk about the charging. So we know that charging, so the main factor, like many peoples are still afraid for not buying the EVs, are the charging problem, like whether there is availability of charger. So we can say there are many initiatives and the policies which the government has been introducing for the attracting EV to the customers. So what are they? So if we talk about the FAME 1, FAME 2, all these policies, what they did, they have given subsidies and also they have given the initiative to the person to set up the charging station so that the EV can be charged. So if we talk about the charging station, so it is being classified into three types: the AC level 1, level 2, and the DC fast charger. So if you talk about the AC level 1, so the voltage, the current, and the charging holds, and also how much time it will take to charge. So it is being mentioned onto the screen. Then we have here the AC level 2, so the voltage level, the ampere, and the load, and also the charge, like in how much duration it take to completely charge. Then we have the DC fast charging. So in DC fast charging, the voltage level, the current, like the current increases, and also the load, and also because of DC fast charging, we can get up to 80% of charging within 30 to 20 to 30 minutes. So this is how we can see the variation of the EV charging, like the level 1, level 2, and the DC fast charging. So it is being categorized into the three level, AC level 1, level 2, and the DC fast charger. Now, what are the challenges in battery pack? Like if we talk about the battery as well as the charger, so first of all, we'll talk about the battery challenges. So challenges which are being seen into the battery are the long life, then the low cost, and the safety and the reliability. So first thing I will talk about the long life. So if we are maintaining a proper using, like when we buy a battery pack, there are some instruction mentioned, like we should charge the battery within this percentage, like 20 to 80%. So if we proper do the follow, if we proper follow that instruction, then what will happen there, the battery life will be enhanced, and also it has a longer battery life. So now talking about the low cost. So low cost, if we talk about, if the manufacturing of lithium ion cells started in India, then the cost of the battery pack will itself reduced. Then we talk about the safety and the reliability. So first of all, like there are many cases into which the two-wheelers has got fire, like the battery pack. So for to overcome that thing is what we have to do, we have to install a proper BMS. So BMS monitors each and every cells, like if any cells exceed the required temperature or the normal temperature, the BMS will turn off the circuit, and also it will give the command to the BTMS, which is the battery thermal management system, to turn on the to do the proper thermal management, which is the air cooling, liquid cooling, or the phase change materials. So these are the safety challenges or the battery pack challenges which you can see onto the screen. Now the charging infrastructure, yes, like there are lack of charging infrastructure, like everywhere we cannot see the charging point available. Okay, and also if we talk about the charging thing, many people are afraid that if we have to plug the charger for long duration of time. So what will happen, because of that long duration of charging, many people still are thinking that we should develop a new fast charging. So for that, the fast charging is also being, fast charging stations are also being built, but it is recommended that we should not charge the battery with fast charging each and every time. Because what happens, because if we are doing the fast charging, what will happen, there will be high amount of current will be flowed into the battery pack, and because of that the battery life degrades somehow. Like it will not degrade immediately, but if we are doing the fast charging every day, then it what will happen, the battery life will degrade. Now we talked about the EV, the battery, the charging, and the motor control. Now we'll talk about more into the EV, like we can say, like I talked about only electric vehicles. Now I will talking about the hybrid electric vehicle, the plug-in hybrid electric vehicle, and the fuel cell hybrid electric vehicle. So first of all, I'll talk about the hybrid. So hybrid means like two combination of two things. The first one, it is engine and battery the motor. So if we combine engine and motor, what will happen? It become hybrid. So these concept vehicles are also available into the market, like BMW i8, i3, Toyota Prius. So these are the different hybrid electric vehicles. So hybrid electric vehicles are also characterized onto the degree of hybridization, like how much energy we are giving to the engine as well as the motor. Then we are according to the architecture as like the series hybrid electric vehicle, parallel, series parallel, and the complex hybrid electric vehicle. Then we have here the number of motor. So if we are using the motor, like the number of motor is being changed, like one motor is used, then what we do, we connect a differential and then we move the vehicle. Then we have the two motor, like if we connect one motor at the another wheel and the second motor at the another wheel at the rear part, so that also will is an option. But to do that, we require a proper control method and the motor drive, which is taking the vehicle cost and expensive, like it is making the vehicle expensive. Then we also have the position, like position based electric vehicles, either the ICE vehicles as well as the electric vehicles. So here, this is an architecture. So you can see here the 48 volt battery and 12 volt. So I already told, like in EV, we have 48 volt, like which is the to give the power to the motor, and we have the auxiliary components into the electric vehicles also. So to make the auxiliary component run, this 48 volt is being converted to 12 volt by the use of converter, which is the buck converter, and 8 to 12 volt, it gives the power to the auxiliary components. So here it is an motor, you can see here, and this is the battery pack. So this is the inside view of the EV, like a basic, you can say. Now we'll move toward the full hybrid. So first one, you can talk about, we can talk about, which is parallel hybrid vehicles. So in this hybrid, so whenever I say hybrid, it means that both engine as well as the motor will be present there. So if we talk about, sorry, parallel. Yeah, sorry. So if we talk about this parallel hybrid electric vehicle, so you can see battery pack, the inverter, the motor, as well as the engine and the transmission here. So if we see here that the engine and the motor, so if the motor is directly connected to this engine, sorry, transmission, which is the axle, you can see, and this engine is also connected